Hi, everyone. Welcome to today's iteration of our contractor workshop series. This is hosted by Chaffee County through a grant with the Colorado Energy Office. We really appreciate having you all here to talk about the solar ready and electric ready codes. We'll have Chad Chadwick from the building department and Tim from Peak Solar talking to us today. But before we get started, I just wanted to let you know about a couple other upcoming events. June 9th will be our next workshop on manual JDS. I know we had a lot of interest in that topic. That will be an online topic, and then we'll have an in-person workshop if you want to do that in like a hybrid situation. And then August 25th, we're putting together a heat pump installation training. So if you or anybody on your team is interested in learning more about actually installing heat pumps, we'll have some folks coming down from Denver, from the state, hosting that training. So more info on that in the future. But if you're interested, please let me know and we'll get you on the list for that. It is going to be free for folks. So I think without further ado, I'll hand it over to Chad.
Are those two items on the energy code sign-in list, or are those
yes,
individual?
Yeah, we'll get them out to that list as well. So if you're on that email list, we'll send that info. Yeah, thanks.
Great. For those of you who don't know me, I'm Chad Chadwick, the Chief Building Official for Chaffee County. We have a presentation. Are you going to flip slides for me?
Yeah.
Okay. We have a presentation today on the 2023 Colorado Model Electric and Solar Ready Code, obviously presented by the Building Department and along with coordination with the Sustainability Coordinator as part of our Energy Code Grant Workshop series that we've been putting on. I know several of you have been to more than one. So welcome and thank you for coming. And we will cruise on to the next. The historical overview of this code. So the Chaffee County adopted it on March 1st of 2024. This was a Colorado state mandated model energy code per legislation. It required jurisdictions to adopt the model code in conjunction with the International Energy Conservation Code. That would be the 2021 International IECC. In its entirety, basically the legislation mandated that we had to adopt the 2021 Energy Code in its entirety along with this model electric and solar ready code. So that's what we did. So released, and it was released by and written by the Colorado Energy Office. So this code, let me pull it up on here, it'll be quicker. Basically, the intent of the code is to regulate the design and construction of buildings to prepare the new buildings for solar, photovoltaic, or solar thermal, electrical vehicle charging infrastructure, and electrification of building systems. This code is intended to provide flexibility and balance upfront construction costs with future costs to retrofit buildings to accommodate these systems. This code is not intended to abridge safety, health, or environmental requirements contained in applicable codes or ordinances. So the idea is that by preparing buildings with future installations for electricity, it does give the building occupant or owner more option, and it should make it cheaper in the future to electrify those buildings if it does come to that, if that's what they decide they want to do in the future. As far as where the state's going, if they're planning on trying to require more all electric, we don't know that yet. We're just kind of taking legislation as it comes. But that's basically the idea. That's the intent of it. So, and then the applicability. So for residential structures, it's all new construction. Alterations to or more than 50% of the existing structure. That was actually left open in the code and decided by the building department, and we took that 50% number out of the International Existing Building Code as a level 3 alteration being the highest one. It kind of made sense to stick with the codes, whenever you put these numbers in here. And then also there's kind of a caveat that we look at each alteration differently. If you're not altering, if you don't have room in your electrical panel, you're not altering that system, you're not forced to do that in an alteration. That's just not, we can't do that. So, and it's similar in commercial structures where all new construction, it is required, and then also alterations where basically the electrical service and systems are being upgraded with sufficient load capacity capability. And if you guys have any questions, feel free to pop them out as we go. Okay. Yeah, so there's been a lot of commercial alterations recently. We're starting to see some more new stuff now, but last year especially, there's a lot of alterations. So it kind of depends on what the level is, how far they're taking it, whether or not they're going to upgrade the electrical system to meet these to meet what's going to be the demand on the load on the system for these requirements. So that's been the hardest part to review, is the alteration stuff for this code so far. There is a waiver and variance section, code section 102.1. Commercial buildings greater than 10,000 square feet or buildings impacted by a natural disaster and a substantial cost differential. So the commercial buildings greater than 10,000 square feet have to prove that there would be a substantial cost differential to be able to apply for this waiver, to either lessen the code or change it in that way where not everything would be required. The substantial cost differential can also be used for residential buildings as well as a waiver and variance. And then when we're talking about what is required in the code on construction documents, location and size of the solar ready zone, structural design loads of roof dead load and roof live load, pathways for routing of conduit from solar ready zone to the electrical service panel, number and location of any required EV capable light spaces, EV capable spaces, ready spaces, or EVSE installed spaces. I have definitions on those later in the slide. Location of conduit and termination points serving the aforementioned parking spaces, and location for condensate drainage where combustion equipment for space and water heating is installed. With our plans, we've been reviewing them, for this code. The solar ready zone on the roof is huge. That needs to be on there. Sometimes the pathways aren't always on there. Sometimes that's determined later. So between the plan review and then the inspection, that's kind of how we've been doing it, because each job's a little different. Tim may be able to shed a little more light with some examples he has of solar ready stuff. But yeah, so what we can get on the plan review, we get there. We check it. We make notes as to what is required. If for some reason it doesn't look like that's going to work or something along those lines, each plan is different. And then also through inspection, the electrical inspectors are all aware of all this, and they've been enforcing this since March of 24. We're getting better at being compliant with this code, and also the enforcement piece of it too. It's taking time for both, all of us basically.
So question on,
Mm-hmm.
say the structure of the roof of an old building in a commercial application especially. So if we're altering a building but not changing the roof structure, and the roof structure wasn't sound enough to put panels on the roof,
then yeah, I wouldn't require you to do that. No, I would not.
Could be.
Yeah, I mean, and then it depends on if they get to a level where if the roof is that bad where they need to fix it, then it would have to be re-engineered to possibly hold that load. But if it's not being touched, existing is existing until you touch it and change it, and then at that point we start looking at what's going to work best for each building. We're trying to work with folks on different projects to a point where it's like, well, is that actually going to work, and does it actually even make sense in this location? And a little bit of working with folks to try to get those things figured out on that kind of stuff. So and then this is kind of a little bit of a repeat here, so I apologize, but this is what the code actually applies. This is the electric ready portion, which the electric ready basically is where you install a gas appliance now, you have to run, a pathway and account for space in your panel for that to be replaced with an electrical appliance in the future. So that does apply to all new construction, major renovations and additions, for residential, and for commercial, all new buildings, additions, and first tenant finishes. So if there's subsequent tenant finishes, then obviously that wouldn't apply at that point. Commercial requirements are broken out into, there's that 10,000 square foot number again, and then all our occupancies in the building code, the International Building Code, and then commercial buildings over 10,000 square feet. And then just go into this a little more, excuse me. So the residential electric infrastructure, combustion equipment, a dedicated appropriately phased branch circuit size to accommodate future electric equipment or appliances. An electric receptacle or junction box that meets the requirements of section RE 302.5, which I don't know if we got that on here or not. Adjacent and is connected to the electrical panel through the branch circuit. Where combustion equipment is used for space or water heating, dedicated physical space shall be provided for future electric equipment. That third item has been one of the harder ones that we've run into on this. That dedicated space, and since we're talking about everything in the future, no one really knows what size these appliances are going to be in 10 years, 15 years, how efficient they're going to be. Honestly, what wire you're going to want to run to it. So basically, enforcement-wise, we've been mainly just making sure there's a pathway there to that appliance, and then space in the panel for the ease of that future installation, which I believe does meet the intent of the code. Because at this point, but making extra space in your mechanical room and stuff seems to be the trickiest thing. Some electric water heating devices are fairly small, some are really big. So it just depends on what the person uses. So that's been one of the bigger ones to keep in mind for everybody when they're designing and installing all this stuff. And then let's see. Yeah, sorry, next slide. And then again, as I kind of touched on the electrical panel space, this is probably what I feel like is one of the most important parts of the code, because you cannot install additional electrical appliances if you don't have space in the panel, and the panel's not sized for the load of those appliances as well. So what we've been seeing is a lot of places are kind of upsizing their panels. They basically have to meet this, especially when it comes into the EV charging, the electrical vehicle charging. So that's a huge important part for electricians and also electrical designers to remember. Labeling the junction box or receptacle on the dedicated circuit breaker space serving future electric equipment or appliances in the electrical panel shall be labeled for their intended use. This has been something that I'm still working on getting my guys to remember to enforce and get, but technically if you have a junction box there with either a wire or a raceway in it, it needs to be labeled as to what the future is. Technically, the electrical panel is also supposed to be labeled. Those blank spaces are supposed to be labeled what they're reserved for future installations. So we will get there, just to warn you. That will be coming up from time to time. Not a horrible correction to have, pretty easy, but and then this word, just adjacency. The electrical receptacle or junction box must be provided within 3 feet of the combustion equipment or appliances, or within 3 feet of the dedicated physical space for future electric equipment or appliances. There's an exception for combustion equipment dedicated to space or water heating. The electrical receptacle or junction box shall be located not more than 6 feet from the combustion equipment or the dedicated physical space for future electric equipment. So yeah, again, it's just that, and then taking into account that dedicated space and then where that is. That's why sometimes a raceway makes more sense to me as well. So that's kind of what we've been doing with that. And then this one's kind of funny, but and then a condensate drain. So basically any combustion equipment installed, which most of them require condensate drain as well, but a location shall be provided for the condensate drainage because the electric's going to have that as well. So that's good. Thanks. Okay, moving on to chapter 4. This is the solar ready stuff, which Tim is going to fill us in a little bit more. Having more expertise in that category, I would say. So for new residential buildings with not less than 600 square foot of roof area orientated between 110 degrees and 270 degrees of true north, that is a low sloped roof. Low slope is pretty low. I think the definition, what the intent here is and what it actually is in the code, they're two different things, to be honest with you. But the important thing to remember is when you go to solar ready, it's actually only required on new residential buildings. So earlier when I said alterations, some of that, the solar ready stuff is only technically required on new residential buildings. So that 50% doesn't play. It's this section here. And then commercial solar ready zones shall be located on the roof of all new commercial buildings that are the same, between 110 and 270 degrees of true north. Some of the design stuff with that, I've seen buildings kind of orientated now with the roof slopes to that between 110 and 270 to meet, that requirement to have that solar there. That's not always an option here in our city of Slider and BV or Poncha, some places, because it's pretty straightforward unless you do, some kind of hip roof or something, but then you probably don't have your square footage at that point, depending on the size of the structure. So it's kind of tricky. That's another tricky one that's been kind of difficult to review and enforce. But as long as they have the future installation. And again, the solar is another industry where the technology's moving forward, getting better and better and better. So here, by the time some of this future stuff comes in, they may have a whole different setup, or it can be on the north side of the building and still work, something along those lines, just as a rough example or something. So and then on the construction documents concerning the solar ready zones, you show the zone, obstructions, shading, roof load documentation, which added about interconnection pathways and electrical service reserve space. That we're not going to see all this on residential. Solar ready zone's been pretty solid. Shading is a really, really tricky one to have. Obviously, what I've seen is when architects or designers lay out the solar ready zone, they just say no penetrations in this area, or obstructions. Roof load documentation is already included on residential, and then the interconnection pathways, again, sometimes we see that, and then sometimes it's inspected at the rough end inspections just to make sure that we're getting it covered on both ends. So
shading is like a building.
Trees or a building.
So what if I was building a building next door to a building where it would then shade the neighbor? Is that restrict my?
It could. We have to take a look at it. It might even be something that we look at, like for the waiver stuff, because it would cost you a lot of money and you're not going to gain that back if you're shaded all the time, kind of thing.
Well, like if it's a neighboring property, they're not even.
You can't. Yeah, there's nothing you can do about the neighboring property. Yeah. So that would be something to look at. That's a really good question, actually. It's kind of strange, but yeah, technically that's supposed to be shown on the plans. Very rarely do we ever see that ever. Here in Colorado, there's less shade than sun, I would say, but it does happen. Yeah. So next slide, please. Okay, and then the reserve space in the panels. The main electrical service panel should have sufficient reserve space to allow installation of a dual pole circuit breaker for future solar electric installation, and shall be labeled for future solar electric. The reserve space shall be positioned at the opposite load end from the input feeder location or main circuit location. The opposite end is actually a requirement in the National Electrical Code as well. So that's why that's supposed to be reserved furthest away from the service wires. And then let's see this. The commercial changes just slightly. It shall have a minimum bus rating of not less than 200 amps. The main electrical service panel shall have sufficient space allowed to install a dual pole circuit breaker, future solar, labeled the same, positioned at the opposite end. So it's pretty much the same, except they're requiring not less than 200. Now here in Chaffee County, XL doesn't do anything less than 200, and Sangre de Cristo is actually moving up to 320 or 400 cans at this point due to the service load that some of this electrical infrastructure they foresee coming down the line. So XL will probably get to that point to it sooner than later, I would think. So yeah, just to kind of get it so we're already at 200 amps. I don't know the last time I saw there's probably a pretty small commercial that was just 200 amps. Usually they're larger than that. So that's that section. And then we've got our electric vehicle ready. So for the residential, each dwelling unit with a dedicated attached or detached garage or other on-site designated parking provided for the dwelling unit shall be provided with one EV ready space per dwelling unit. Each EV ready space shall have a branch circuit that complies with all the following. Terminates at a receptacle within 3 feet of the space, includes 2 adjacent parking spaces. If the receptacle for the electrical facilities of this section is installed adjacent to and between both parking spaces. So you can use one receptacle for multiple spaces as long as it's within that parameter of length. It has a minimum circuit capacity of 8.3, 40 amps, 208, 240 volt. So yeah, they're just giving you a minimum there that you can do it at, which would be 40. I don't, most electricians I see doing it at a 50 or 60, just to cover it, because again, you don't know. So many different kinds of electrical vehicles. Some plug into 110, some plug into 50 amp. It varies from each one. So better to be covered on that. So, and then the electrical panel, electrical distribution equipment directory, and all outlets or enclosures shall be marked for future electric vehicle supply equipment. Again, this is one that we've kind of been missing on enforcement, and maybe we're still all learning to know it. So we're going to try to pick that up a little bit. Again, not a horrible thing to correct. Go ahead. And then the commercial electrical vehicle power transfer infrastructure, where a new parking is provided for commercial buildings, it shall be provided with electrical vehicle power transfer infrastructure. The number of required EV SE installed spaces, EV ready spaces, EV capable spaces, and EV capable light spaces shall be determined in accordance with this section and the table. I did not include the table, but I do have the code here if we have questions about it. Based on the total number of provided vehicle parking spaces and shall be rounded up to the nearest whole number. This includes all covered parking under carports or detached garages. So the residential, not horribly. The commercial gets a little more complicated because each one of these different designated spaces has a different number on the table that you have to meet required. Most of the designs I've been seeing just go ahead and do the EV ready space, and then it kind of covers you to the best of the ability. I believe that's, I'm not going to have it memorized. It's some amount in 50 spaces. I want to say it's 4, but anyway. So that's what you're seeing. You guys are probably seeing more EV charging around the city, around Buena Vista. There's also another, I don't know what exactly to call it, EV initiative that's also going through the respective zoning departments as part of their review as well. So we're kind of getting EV on top of EV. so there's going to be more and more of that as we move forward. So pretty not horrible in residential, as again it only requires a pathway to a box and then the space in the panel. However the electrician decides to do that. Again, that makes sense to me because eventually when the house is sold, they might have some particular EV that has a particular plug, that has a particular voltage and amperage. So makes sense to me to just make it for future, or maybe they don't even have an EV car. They don't even want to use it. Maybe there will be a future resident that does. So that's where this code kind of makes sense to me as an electrician, because I was always about putting conduits in for future things. So it's so much easier for the next guy. I mean, the trade is all about just making it easier for the next sorry electrician that shows up and has to do stuff there. So yeah, in that way, it makes sense to me for that portion. And then these are just some of the definitions for those for the commercial, because it gets kind of strange. So you have the capable light space, designated vehicle parking space that has conduit and or raceway installed to support future implementation of electrical vehicle charging installation, and has sufficient physical space adjacent to the existing electrical equipment for future electrical upgrades. It's a mouthful. So capable space is designated vehicle as electrical panel capacity and conduit and or raceway installed to support future implementation of electrical vehicle charging. And then a ready space has the raceway, wiring, receptacle, and circuit overprotection devices, everything in place to do that. So basically, I don't know how interested you guys are in the commercial, but there's a table in the code that if you do so many of these capable spaces, then you have to do this many per the amount of parking spaces, and so on and so forth. The EV ready is the least, obviously, because it's all set to go. So that's mainly what I've been seeing on my reviews. Any questions on anything thus far? Kind of blowing through this one. Okay. Go ahead. Oh, yep, there we go. Questions. Thank you for attending. I did include a couple of links. This is the Google Drive folder from the Energy Office that has the model electric code in it, and it also has the explanatory notes version of it, which is somewhat helpful, as helpful as explanatory notes ever are. And then that's in the toolkit, which we pretty much put up every time we do these. So they do have a lot of really good stuff on there. It's a decent site too for navigating. It's fairly user friendly. So if you guys haven't checked it out and you have questions about anything like this, I would definitely recommend utilizing it. Any questions about anything I covered in the code that wasn't in the slides? Okay.
Really? You guys plan on sharing this?
Yeah. Yeah, so we have the link on our website. I believe it's in 2 different places. I think it's on the general information page and might be on the adopted code page. I don't remember exactly. But there is a link on there that has the energy code workshops, and that link will take you to every workshop we've done so far. This one will be uploaded in the next couple of days or something, or next week. Yeah. So, yep, absolutely. Good? Happy? Tired? Bored? All the above? Okay. Cool. And then I'll take a second to introduce Tim. Tim is with Peak Solar Designs. He does a lot of solar installations in the entire county and outside of the county. They do, through inspection, I've seen his work. They do a great job. So yeah, so he has a little more insight into the actual installation side of solar.
Okay. I was looking for a pointer.
Oh, you got one?
No, she doesn't. Do you have one?
No, I don't have one.
Okay.
Sorry. I have a flashlight.
All right, I'll just kind of point. But anyway, this isn't going to be the most interactive PowerPoint. It's pretty boring. It's just a bunch of pictures. But I've been kind of poking at these guys for a while to try to jump in on this solar ready stuff. We've had a lot of homes recently where we get there, the new homes, everyone's all psyched. Hey, our brand new home, we're solar ready. And we get there and it's like, well, there's a spot for the breaker, but that's about it, you know. And, 2 homes in general last year, they're built by the same builder side by side, and they were in a week and we were already digging up the backyard to run conduit, in their brand new home that's solar ready. So I've just kind of wanted to throw out there some like things to consider to help the homeowner. Especially now that that solar ready label is out there. Just want to, if your homeowner is even mentioned solar, consider it, like reach out to a solar contractor and see if there's something that can be done ahead of time. It'll make it a lot easier. So what we want is a clean installation like this. This is 3 battery storage systems. It is a solar system, but so to back that up, 14 of our last 20 systems have all had battery storage installed with them. So it's gone way beyond solar now. It's solar and storage. And so we're having to prep not only for the solar, but for the storage, because it's a major retrofit to do the storage later on. So this is a good example of what we want it to look like. This is one we were able to rough in. This is just an electrical panel just for these. You can see the other panel over there. But
How much storage is
that one is about 40 kilowatt hours. And this is the transfer switch. Okay, so this is where the retrofit comes in. It gets tricky when you've got a transfer switch. Okay, so and I'll kind of
automatic,
It's an automatic transfer switch, but we got to reroute the feed from the grid through this before it hits that. Okay, and that's where a retrofit gets tricky, and especially on a brand new home where they just finished their drywall and we start cutting it up right as soon as everyone's gone. So, but this is the ideal situation. Next slide, you can see what it looks like if we don't get there in time. And Chad, you'll appreciate the freezer underneath the electrical equipment. But so in this case, we had to. So the main feed comes in, and it comes, loops around to the top. So what we have to do is splice onto that feeder from the grid into this J box. It's a task. Run it over the transfer switch, and then it gets routed back. Okay, it's clean. It looks, for an electrician or someone works in electrical, that's good, clean work. But for a homeowner on a brand new house, when we're doing that, and they think it's solar ready, it's a tricky, it's a fine line to walk there. So, but this is how a retrofit would look, and we just don't want to do this in a brand new home if we can avoid that. So, yeah, the message I want to get across is, if the homeowner even mentions it, just talk to a solar contractor before everything's covered up, so we don't have to do that. Here's another example. This one was even roughed in, and look, you can see the extent of some of the equipment we have to install. This was roughed in, and it still takes this much work sometimes. And once again, it's clean, but you can see there's a lot that goes into it. So just having a spot in the breaker panel doesn't make it all work. Another thing I want to point out too, which I'll kind of hit on, but this one has a production meter and a disconnect required by Senator Cristo. This one's actually on Excel, but just because it's the certain size system, we had to do this. That production meter and disconnect, that's on the AC side of the system. So not the DC from the solar, but from the AC. That, I think, is one of the most important components of a rough-in, is that component. We can get conduit off the roof pretty clean, pretty efficiently, but when you got to come out of the out of the inverter and sometimes go across a garage to get to this and then back to an electrical panel, that's a major chore, because no one wants this by their front door. And a lot of times the service comes in that general area. Well, the easiest thing would be just to punch it out of the wall and back in, but then it's right at their front door. So doing a rough-in, up front, where you have some Romex coming from the area where the inverter may end up being, take it over to the other side of the garage or what have you during rough-in phase, it makes it a lot easier later on.
Well, I struggled with all the panels the last 2 jobs I've done, at 12 feet of panels on the outside of the house. One of them is on the street side, and it's like, that's just terrible.
Yeah. So yeah, you can see there's a lot that can go into some of these. I mean, this was a bigger system for sure, but this was roughed in. So you can see there's still a lot of stuff that needs to go on. Here's an example of a rough-in in the stud bay. So this is the DC from the roof. It has to be a metal conduit, metal clad, basically a metal raceway. This is an MC cabling. And then what we have here is the AC feed. We're talking about how important that is to get that in the wall up front. So we have some Romex here, and you'll see here there's 2 other wires. This is something we've been trying to do on every house that we're roughing in now. The gray wire is the communication wire from the battery to the transfer switch. And then this brown one, which is also real important too, any storage system has to have a push button disconnect on the outside. It's called emergency stop switch. You see them at gas stations. They're red and yellow. Pretty ugly, really. But once again, no one wants that by their front door. So we're trying to make sure we get this stuff. If they say solar and we're there to rough in solar, we pretty much do that anyway, because they're going to probably add storage somewhere down the line. And it's real cheap wire, but what a hassle to put it in later. So, but this is kind of an example on that. And I wish there was more electricians here, but number 6 Romex is what we're asking for everyone, for the electricians, because that covers 99% of the jobs. If we can get that in there, then we're good. We're never going to hit 100%. But if we can get 99, we're pretty good. So that's something we're always asking for. This is kind of the same picture. This one has EMT though, as the DC feed there is coming in through EMT. But you see, we got blocking in the wall. and we have all these in either boxes or conduit. So this is what we consider a rough-in, and that's what we do a lot of these. And of course, we're always there at the last minute because no one thinks about us until the insulators are coming.
So I have them. It's been probably 4 or 5 years since I built one that we were trying to be solar ready then. And that particular job, you were the person I talked to about putting in something future solar. And the advice was, don't even bother. It's not gonna be right if we do it now anyway.
Yeah.
We'll just do it later. So now we can expect it's gonna be right enough that it's gonna work.
Well, it depends. There are certain situations where we don't have to. If we know the panels are going to be on a garage, and we're going to come right down through an attic, right into and we see where everything is going to be laid out, then yeah, it may not be worth the effort. But in certain cases now, and a lot of these homes have flat roofs now or flatter roofs with no attics, that makes it real hard too. And I'll kind of show you an example of that. But the whole geometry of the homes have changed, and so those big open attics they're not there anymore. And a lot of them, even if they're pitched, they're doing the spray foam with a vaulted ceiling. So there goes our what we used to use as our raceways before. We can't do that anymore. So, but yeah, the blocking and all that, this, and we mark on all the studs are marked on, so everyone knows, because we have an electrician works with us 99% of the time, but in some of these new homes, it's not our electrician, so we try to make sure it's all in place.
And that DC feed goes to the roof in this case?
Yeah, that one we go to the roof or to the attic. Sometimes just to do a rough, and if there's an attic space, just running that conduit up into the attic, we tape it off so they can get full insulation. That's great. We usually try to put it right by where the hatch is, so later when we come in, we don't have to crawl across the attic with insulation to get there. So that's where having a solar contractor, there's a few in the county, but they will help with that because no one wants to crawl across that stuff.
Yeah, because in the code, technically all that's required is that.
Yeah.
And then space in the panels. That's what you're saying, is that there's a lot more that should be going into it.
As I said, this is, I think, the most important component of the rough-in is the AC. And I'm a DC guy, but I think we can make that 3/4 inch conduit. We can sneak that around places, but doing all 3 of those wires, that's a tough one, man, because you got to break into an electrical panel to get that, and that's tough. This is the same picture, but another component that is real important. And Sarah, this would be something you would probably be seeing when you're drawing plans. You can see right here is the UFR, okay? So the electrical panel, I believe, there's a couple panels, but they're like right here. The reason we put this to the side is we can't have batteries in front of where a car can pull in, okay? Code does not allow that probably because someone has run their car through it. That's what happens. So we're on the sidewall. That's where we always try to be. That's the safe zone. There is exceptions. You can get the batteries 3 foot off the deck, and we have cases where we've done that. But they're 250, 350 pounds. We don't prefer to do that if we don't have to. But that's where another component of having a contractor there, solar contractor, somebody that understands that, because someone might have just roughed it in right in front of right here, and we wouldn't have been able to use that spot. And then we would have had to go to the whole retrofit later on. This is an example of a rough-in where it's a vaulted ceiling and there's no attic space. So what we do in this is we brought our MC cabling through the walls on that, and we put it in the bell box out here. Our solar panels ended up here. This was during the rough-in, and we just ran a little stick conduit right up and tap into that. So we didn't have to come down on the outside of the building or anything like that. But that's how we can get away getting a rough-in done without an attic space. Sometimes if you've got those kind of roof lines, it's great. Asphalt shingles. We have it's called a Solodeck, and it's just kind of it almost looks like a turtle vent that you see on a roof. And it's a spot where the wires would come in. What's that? It's a big J box, yeah. But it's flashed and everything. What do you probably install a bunch of those? I mean, they're nice. They work real well. Yeah. It's called a Solodeck, SOLADECK. Yeah, they work great, but they only work on asphalt shingles. With this, we knew we were going to be doing this home eventually. It was kind of a homeowner build, and they're waiting to the end for the budget. Well, it's real hard to rough in conduit and have a J box floating just on a metal roof. When we have rails there, we connect it to the rails that mount the solar, but you can't really do that just having this box flap around until they decide they want to do it. So that's the approach we try to do in something like that. This is kind of an internal look of it. Here is, you can see our blocking where our batteries are going. Here's the transfer switch. In this particular case, this SER, you can see the electrician roughed it in like he normally would. He was planning on coming right up in here. Well, this wire actually got rerouted to go to the transfer switch, and then it reroutes back to here. Okay, so once again, it had to be planned ahead of time, or it would have been a pretty ugly deal to do later on. Here's another example. This is an all-in-one with the transfer switch as well. This is a pretty nice one because it's a feed-through panel. It feeds right over to the transfer switch, comes in, breaker, out. You can see it goes right into the electric panel. That's a great way. You know, when we can get there ahead of time and do that, that's really nice. Trying to do that later, it's tough. We can keep it pretty clean, but then you're splicing out all these wires, and you got big ILSCOs in there, and it's just you run out of room pretty quick. Same situation. Here's a 320 amp service. What I was trying to display with this is, you know, most of these bigger services, they have two panels or two disconnects before they enter the building. A lot of these transfer switches are service rated disconnects. So this serves as the disconnect for the house. So this one is a disconnect going to one panel, and then this serves as the disconnect going to the other. And that comes in real handy, so we don't have to have two disconnects in a transfer switch. But once again, new construction, we're able to do that up front. Turned out to be pretty clean. This is another one. Chad, have you seen many of these the meter collar ones?
It's fairly new.
Yeah. So this one is this a particular device. We'll call it. It's called a backup switch, and what it is this comes off of. It's the communication wire that comes off of in this case, a Tesla Powerwall, and there's a little collar that goes behind this meter. In Xcel Energy, this is approved by most utilities. Xcel allows us, or our electrician, to pull this tag, pull the meter off. You put this collar on there. It's about 1.5 inches thick. That's actually the transfer switch. Then the meter goes back on. Okay, and so in a grid outage, it just sends a relay because this collar loses power from the grid, sends a signal to the battery to kick in. Okay. It's really, really slick and easy, and you don't have to bust into panels by doing that. But of course, you can see what it takes to get that. There's still some stuff on the outside of the wall. This here is that rapid shutdown switch, that push button. We've been putting them in these bell boxes. We have to have a big label on them, but we've been putting them in the bell boxes because before they're just red and yellow, and kids will just think that's the coolest thing in the world. And we've had it numerous times. Homeowners call us to say their system isn't working. We also had people put their garbage cans near there, and they flip the lid up, hits it, and turns it off, and they don't know it. And then we're all trying to figure out what's going on. And simply that's all it was. So, but yeah, we've been trying to hide the button, but still, you can see there's a big red label on it. That's not something we want in front of someone's front door. So, in this case, it wasn't that way, but that's what we're trying to avoid. Here's another meter collar. This one actually, rather than just being a signal of a transfer switch, it actually has line voltage in it. So here's the inverter, comes out to a fused disconnect, and this meter collar actually has line voltage going to this meter collar. So in this particular case, and I'll kind of go to the next slide. I wish there was more electricians here so this is always a debate. But this is a way to interconnect this system, and you don't have to worry about the bus rating of the panel. You know, the 120% rule. It avoids all that. You can take 100% of that panel rating into that. So this is a kind of a retrofit feature. It's pretty nice. So I was hoping
feeding from the solar back into the grid.
Yeah, through that meter collar. Okay, grid goes down. This shuts off because there's no battery on this one, but it is a great way of interconnecting. And the reason we couldn't interconnect here is the next slide might have that. And this is always been the debate. Oh, is that it? Okay, you know what? Come back to this one then. Number 10. So let's say this didn't have a transfer switch and we're just connecting solar. The reason we can't just land our solar breaker here and why we have to use a meter collar is these conductors here. Let's say this thing's not, and this is just going into a panel. These conductors here are rated for 200 amps because that's what the breaker is. If we put solar into this, we're actually creating a parallel connection in there. So these conductors could see 200 from here, but they could also see maybe 40 or 60 from our solar. And then these conductors aren't rated for that. This breaker doesn't see our line voltage or our current as a load because it's not pushing power to it. It's just our feeds connecting onto that, okay, and paralleling. So even though there's breaker spots here, we'd have to do a meter collar to meet this. Unless, this is where my question comes in for Chad and electricians, is the whole 10-foot tap rule. Does that, if we were to put a breaker in there with solar, say 40 amp, would those conductors, let's say this was the main panel then right here, or the next panel we'll say that are feeding that, and those conductors are say only 5 foot long. Would the 10-foot tap rule apply to where we could put a breaker there and those conductors being under 10 foot, would they?
I think it would.
In that case it would? Okay. That's always a gray area. We're trying to figure out, like, because sometimes you'll have an all-in-one like this and the main panel's right on the other side of the wall. And so it's like, okay, well, we're within 10 foot, but anytime we feel uncomfortable, we just like, let's just meter collar it. We know we're good. But those aren't cheap. You know, meter collar's $450 and you got a fuse disconnect, you know, it has some cost. So, but a lot of times now, you know, in these homes, you have an all-in-one on the outside. Well, they run those feeders then to the other side of the garage so the electricians aren't running wire across the whole house. Well, then you're way over that 10 foot. So that's how you have to do that. So. But you feel that 10-foot tap rule works in that particular case? Okay, great.
I can research a little bit more too and get back with you.
Yeah. Oh, I've been in so many trainings where, I mean, people are yelling and screaming, no, no, yes, no. And it's just like, okay, then the meter collars came out and everyone's like, let's just do that and not have to worry about it. Because, yeah, certain jurisdictions just don't want it and have you. I think that was the last slide. Is there any particular question? Woody, you got anything to add? You've been on both sides of the AC and DC of it. Now you've spent a year plus on each side.
Yeah.
Anything on the roughing you think that would help?
Not that I can think of offhand. No.
Okay.
No, not.
Yeah. We use a lot of gutters, electrical gutters on our stuff. We did one with Woody and Riley not too long ago, and it's very industrial looking, but it's very clean, you know, and sometimes that's the way to do it. But yeah, we've done a couple of, the one just down the street, Alyssa's, we wouldn't have been able to rough, if we wouldn't have roughed that in, and it would have been you imagine that would have been a pain. Yeah, and we're in the basement. So to try to get everything down later on, it would have been a nightmare. So, yeah, so having that up front, you know, it makes a big deal. Okay.
Can you give us some idea of cost involved with these rough-ins?
So yeah, I mean, we've done rough-ins for like $250 up to like probably $1,800. Okay, you know, 1,800 would be where just the location of the equipment, you know, is just not next to each other. We have to do a lot of stuff back and forth. But I'd say the average probably $850 probably, just to. But you know, if you're going with the full storage situation, that's really hard to, you know, that takes a few people, you know, electrician and us scratch our head, okay, how can we make this work? You know, that cost could be more for sure, but just for a basic solar rough-in, probably $850, you know, would be the average. Catching it up front for storage is way easier. Yeah. But to retrofit it, you're thousands right there, easy, just in labor and materials. Gutters are not cheap.
I guess that's kind of where the code's lacking because it doesn't require dedicated storage space for solar.
Yeah.
Which would be actually somewhat useful.
And it's
Okay.
it's I said 14 out of our last 20 jobs I had storage on it, and it's like it's
Yeah,
a
I love
major.
that.
So all of our rough-ins now, we're just trying to get really prepared for that because it's
Is
hard.
that another third in cost, or maybe more than that, the storage?
A third would be a good, yeah, to a general storage system between 15, 16 grand, somewhere in there. Um, to retrofit it gets a little higher for sure, but if we do it up front, it's a lot easier. But yeah, I mean, our average system costs probably 40 grand. So, but that's, we're in a new administration right now, so things are a little. Actually, the storage component's still really going hard. Senator Crystal's doing rebates for storage right now, so it's not huge, but it's a little bit. So we're doing a lot of retrofits right now. We're quoting a lot of retrofits.
You looked at a job for me when we talked about batteries. Did you tell me they couldn't go in the basement?
You got to have working clearances, typical electrical working clearance, 6.5 feet, 3 foot. You really don't. Yeah, there has to be some kind of, like a 1 hour fire rating around.
Between it and the structure.
Yeah. So a lot of companies will only put batteries outside for that reason. It just kind of gets them around it. I'm not a fan of that. They operate down to -4 because they all have internal heaters in them now. But I'm not going to put that outside and have it be -20 and void a warranty. I mean, all these battery companies say, "Oh, don't worry about it. Don't worry about it. It'll be fine." Yeah. So we go into a garage 99% of the time because they have 1 hour fire rating on a garage. I mean, it's required. So it makes it pretty easy. And having the required disconnect on a building now, that helps a ton. Because a lot of the old school electricians that were really good, I mean, they would bring their conduit up in the slab, right into the wall, and you can't get to the feeders. Now there's an LB or a disconnect on the outside or something, and we've actually taken the disconnects off and replaced it with a transfer switch. It's serving the same purpose. So that helps a ton. All right, that's all I got.